Welcome students. In this topic, let us look at a very important concept called the common tangents of circles. Common tangents to circles. So in this topic, the topics that we're going to learn are, we're going to learn what common tangents are, what common tangents are, and the types of common tangents. What are the types of common tangents? That's the first question that we're going to deal with. The second, what is the number of common tangents that can be drawn to two circles? Number of common tangents that can be drawn. Third, the equations of common tangents. So once you understand how many common tangents can be drawn, what are their equations and what are the lengths of common tangents. So the fourth topic is the lengths of common tangents, and finally we'll go and see if there are some special properties to these tangents. Special properties of these tangents. First question, what is a common tangent? It is simply a line which is tangential to both the circles. If you have two circles, if you have a line which is tangential to both the circles, then it is called a common tangent. As simple as that. So as you can see, I have drawn this line. If you see this line, this is touching the circle at this point and touching the circle at this point. So this is a common tangent. Similarly, if you take this line is also touching the first circle as well as the second circle. So this is also a common tangent. Next, if you go to this line is also touching the first circle here and the second circle here. This is also a common tangent. And if you take this line, this is also a common tangent. So there are four common tangents to these two circles. Next, common tangents are of two types: direct common tangent, and transverse common tangent. Direct common tangent and transverse common tangent. What is a direct common tangent? It is a tangent for which the centers of both the circles lie on the same side of the line. So if you take this common tangent, you can see that both the centers of the circles are lying on same side of this line. So this is a direct common tangent, DCT. Similarly, if you take this line, for this line also, both the centers lie on the same side of the line, and this is also a direct common tangent. Transverse common tangent are those tangents for which the centers of the circles lie on the opposite side of the line. So if you take this line, one center lies on this side of the line, the other center lies on that side of the line. So if you extend this line, both the centers lie on opposite side of the line. Hence, this is a transverse common tangent. This line is also a transverse common tangent. So first question has been answered. What is a common tangent and what are the types of common tangents? Direct common tangent and transverse common tangent. Next, how many common tangents are possible for two circles? For these two circles, you can see that there are a total of four common tangents: two direct common tangents and two transverse common tangents. So can I say that any two circles will always have four common tangents? No. The number of common tangents depends on position of circles with respect to each other. So there are different cases where the number of common tangents change. So let us look into that. Next, how do you find the equations of common tangents? So the equations of common tangents can be found using the concept of similar triangles. Concept of similar triangles. So one of the important property of common tangents is that the points of intersection of the direct common tangents as well as the transverse common tangent lie on the line joining the centers of the circles. So if you join C1, C2 and extend them, the point of intersection of direct common tangents will be a point on this line outside C1, C2, and the point of intersection of transverse common tangents is a point on this line inside the line segment C1, C2. And this P dash and P satisfies a very important special property, which is the points P and P dash divide C1, C2 in the ratio of the radii, one internally and the other externally. You can very clearly see this. This is R1, this is R2. So if you draw the radius, the distance, the angle between the radius and tangent is 90. The angle between the radius and tangent is 90. So can you see that triangle P dash C1A and P dash C2B are similar to each other? So can I say that C1P by C2P, C1P by C2P is equal to R1 by R2? P dash C1 P dash by C2 P dash is equal to R1 by R2. This, that small triangle and the big triangle are similar, and the ratio of the sides is equal to the ratio of the other two sides. It means P dash divides C1 C2 in the ratio R1 is to R2 externally. Similarly, if you take this point P, if you draw this radius and this radius, this is R1, this is R2. If this point is C, if this point is D, can you see that this triangle is similar to this triangle? Vertically opposite angles are equal, 90, 90 is equal. So two angles are equal implies these two are similar. So here also C1 P by PC2 is also equal to R1 by R2. So this is a very important property which you need to remember. The points of intersection of tangents divide the line segment joining the centers in the ratio of the radii. One external division, the other internal division. So using this concept, we'll try to find the common tangents equations. Next, we'll go to see the lengths of common tangents. The distance between A and B, the distance between the points of contact is called the length of common tangent. So AB is the length of direct common tangent, or CD is the length of transverse common tangent. AB is the length of direct common tangent, CD is the length of transverse common tangent. And let us see how to find these lengths if the circles are given. So I hope you understand what we are going to see in this topic. Now, because we have answered the first question, let us go to the second question. It is the number of common tangents.